I'm Sara. It's nice to meet you guys. I can't really see you guys. It's bright up here. So I'm here today to talk to you guys about building a hardware company. So I have been building software for about 15 years now, almost 15 years, which is crazy. It's a really long time. And a couple of years ago, I got kind of obsessed with hardware and hardware culture because I discovered the ability to build things with my hands, which is super fun. And what I experienced on the way is just a lot of learnings around the difference between software and hardware. And I think the biggest thing I learned in general, and like I said, I built software for a very long time, so I love software, and I love the community behind the people that build software, but one of the major learnings I had is that software is pretend. It's just, it lives in a computer, and it's a bunch of ones and zeros, and hardware are things you physically build with your hands, and there's so many, it's like building software to the nth dimension. It's pretty wild. So today I'm going to talk a little bit about my journey, our journey building a hardware company, some troubles we ran into along the way, how, and stuff that we took with us. So a little bit more about me. I am a JavaScript developer. I've been doing that for a long time. In 2010, I started an organization called Girl Develop It. We do low-cost software development classes geared towards women. Girl Develop It is in 47 cities now and has taught over 17,000 women how to code, which has been an awesome experience. Girl Develop It is still growing super fast. And from there, I went on to an organization called Flatiron School, which is a program that teaches adults how to code. So I was CTO of Flatiron School, and that was my last job before I left it and went to start a hardware company. So this talk is about my journey from hacking to building to growing a company, prototypes, things like that. So it begins in fun. So I was told to say when to play so play it. The engineers here are super awesome. They're some of the nicest I've met. So so I fell in love with a lot of hardware projects that came out of the software community. This is a gentleman named Rick Waldron. You'll learn more about him during my talk. But he builds hardware using JavaScript, which is so cool, which kind of got me into hardware in general. So I'll start with that journey. OK, so this talk is about what I've learned as a professional, some cool videos of hardware, some tips for prototyping, things we learned during user testing, and manufacturing steps. Also, I'm giving away a Spark core at the end of this talk. So if you stick around, you might win a Spark core. So this all started in Dublin in 2012. I went to a conference called Node Summit, talking about JavaScript and software. And Node Summit was in the Guinness factory, which was like awesome. That's how I kind of started to like Guinness. I hadn't liked Guinness before. But they turned the taps on at like 10 a.m. It was crazy. And so one of the talks I saw, which is like primarily a software conference, but one of the talks I saw was about hardware and building hardware. And it's this woman named Emily Rose. And she was pretty cool. And the thing she talked about was pretty cool. There's this one guy named James, who's a friend of mine. He went on stage with an AR drone, a Parrot AR drone. Those are those like quadcopters. And he had programmed the drone to charge every time it saw the color red. So he was bullfighting the drone on stage, which was awesome. That was really cool to see. And so Emily Rose came on stage, and she was like, OK, guys, listen. I've programmed this fog machine to work with JavaScript. Last night, I blew out the electricity in my hotel room. My hotel room wall is brown. The whole electricity in the hotel went out. I don't know. It's the converter. I don't know if this is going to work or not. But I figure, like, I worked on this. I came all this way. I'm going to try it. So She plugged the thing in, she's like, all right, so this is a fog machine using JavaScript. And then this happened. And then the entire room, much bigger than this room, is maybe like twice the size of this room. But no, maybe like 3 times the size of this room, filled up with fog, machine fog. No one could see anything. You could see the security guards from Guinness like running in, being like, what is going on right now? It was the craziest thing I've ever seen, and I was like, that is awesome. I need to learn how to do that. That was the most fun thing I've ever seen. Much more fun than software talks, which are like so boring. And I can say that because I've given a bunch of them. So I went up to Emily Rose afterwards, and I was like, this is so cool. I don't know how to do what you do, but I really want to do it. And so she gave me this little baggie full of LEDs, and she was like, here are some LEDs. What you need to do is make them light up. That's the first thing you do. Just go and make these LEDs light up. And for me, I was like, that's the craziest thing I've ever thought of. I don't know how to do that, but I'm going to figure it out. So I reached out to a friend of mine, a guy named Rick Waldron. He made a library called Johnny 5. Johnny 5 is a library for JavaScript that allows you to program for Arduino using JavaScript, which is a lot easier for me because I was a JavaScript programmer, and most Arduino code is written in C or C++. So I reached out to Rick, and I was like, listen, we're going to do a hack weekend. Why don't you come by? You can tell us about Johnny 5. We'll have a whole bunch of people over, and we'd all love to learn about it. So he was like, all right, great. So we all got together for a hack weekend, and we built stuff over the weekend. So this is it's a video of my first hack. You can go ahead and play this video. It's pretty astounding, you guys. Wait for it. And that is an LED changing colors. How about that? I know, I was so stoked. It was super fun. So that was my hack that weekend, and it felt awesome. I was looking at this thing, and I was like, I am a god. I just made this thing light up in front of me. It was pretty amazing. This is the best hack that came out of that weekend. It really deserves more time than my light up. I'll tell you when to play it. 1 second. So my coworker at the time, Francis, he built a device that used a Raspberry Pi, a MiFi, a breadboard, an Arduino Uno, and a servo to do this. You can play it now. From the internet. So one thing that was annoying about our office is we had to get up and let people in every time someone knocked at the door. So he set this up so we could open it from the internet. And it took him like 20 hours. It was the longest project, but it was super valuable. So that was my favorite hack of that weekend. So at that point, I was like bitten by the bug. I was so excited. You know, like hardware is where it is. So coming up after that was a thing called the Node Knockout, which is a competition worldwide for people that write Node.js. And the Node Knockout is kind of like the Rails Rumble, if you've ever heard of it. There's 700 teams around the world competing against each other, trying to win like 7 prizes. And so what we did, we tried to think of the most ludicrous thing we could do. So we made this awesome Christmas sweater that talks to the internet. So basically, you go on a website, and you type in a sentence, and it shows up on this Christmas sweater. Equally the most awesome and useless thing I've ever done. But we won the Node Knockout. We won the Innovation Award, which was super awesome. So from there, I got more and more comfortable with hardware. So I kind of wanted to go into making a project of my own, like something to build. And I wanted to make something that was really attractive, something that, you know, one of my interests is like fashion and jewelry and all those things. So I was like, why not make a wearable? So I decided to make a necklace that changed color based on your tweets. So I was like, you know, if you're if you like do sentiment analysis against your tweet, if something's an angry tweet, your necklace might turn red. So I did all this research. I found Femtoduino, which is a super, super tiny Arduino. It's like less than an inch long and about a half an inch wide. And I found all these other things that were small. And then I was like, I need to find something to put them in. So I went on Etsy to find if I could like get a locket that was big enough, and I couldn't do that. So I ended up with this, which is not very beautiful. This is my first creation. That's like a Christmas ornament. And if you can see in this picture, I like tried to wear all these other bulky necklaces to make it look like not as awful and not as ugly. So that was my first try. But it worked, at least. I wouldn't want to wear it anywhere. So the next thing I did from there, it's the same thing like software, except a much longer iteration. So when you come to an MVP in software, you can pretty much do it. You can build almost anything in 6 to 8 weeks. Like, it's not the best version of anything by any means, but 6 to 8 weeks, and you can get a really good prototype up and running. And my experience with hardware is similar, except it's more like 6 to 9 months. Like, in 6 to 9 months, you can get a really crappy version of something going. So I figured iterate on it. So the next thing I did is I went on Etsy and I found someone that designed 3D light up jewelry. He did some pretty cool stuff, and I reached out to him and I was like, do you mind designing a necklace for me? And he was like, great. So he did, and then I found some smaller components to make something smaller, and I ended up with this, which is a little bit better looking, much better looking than the original thing I did. And I open sourced all of the design files, the code for the hardware, everything. If anyone decides to make one of these, please let me know, because I'd love to answer any questions, because it took me forever. So feel free to go check that out. So from there, I kind of got enamored with the idea of actually building a wearable, like getting into building something that was real, that could be manufactured. And so I started working on this project called JulieBots. And JulieBots was something that came of the idea, so one thing I've been thinking about for a long time is getting kids coding, because something we heard from our adult students a lot, especially women, they were like, I wish I even knew this was an option for me when I was a kid, right? I really wish I even knew computer science was even a major I could do. I didn't even think of it, and that's why I'm in X career, but if I could go back, I would do it so much differently. And that just doesn't apply to everyone, but I've heard that a lot. And so I've been thinking about how to get teenagers more involved. And teenagers are very, you can't tell them what to do, obviously. I was pretty much the worst teenager. But one thing, the way I got into coding is I was 12 and I was a homeschool kid, and I didn't really have that many friends. And I figured out that my computer could call another computer, and I could talk to other people. And that was BBSs. So I figured out how BBSs work. I ended up like talking to grown people, men online, men and women online all day, which is weird when you're 12. But I made friends with lots of people and had a great experience. So for me, it was out of necessity, and you see that all the time, right? I don't know if anyone's of the MySpace generation. Now when I say that, people are like, eh. But all my friends learned how to code because of MySpace at the time. They were all doing HTML and CSS and things like that. And now you can see kids with Minecraft. Kids love Minecraft. And kids teach themselves Java, and they become like tiny little server admins in order to customize their Minecraft for them and their friends. So I started thinking about making a necessity for girls, something that they could use without coding it, but making it open source so they could code it, to see if we can kind of artificially create that. So that's what I started working on. I called it JulieBots. And after a few months of working on JulieBots, we were lucky enough to get into a hardware accelerator called Highway 1, which was an amazing experience. And for us, it was really wild, because we were used to like taping things together and like 3D printing, and now we were working with mechanical engineers and electrical engineers, industrial designers, and people that really knew what they were doing. So that was a really cool experience. And one of the things we heard from them, literally the first day, they're like, this is the most important thing. How many of your users have you talked to? And I was like, I mean, I used to be a teenage girl. I know what they want, right? And they're like, no, it doesn't really work that way. Teenage girls are different now, so go talk to them. So we did. I have spent so much time with teenage girls in the past year. I can't even tell you. And we learned so much about, like, literally over 100 of them. I've talked to over 100 of them to find out what they want and what they're into. And we found some really interesting stuff about them. Our original theory about what we would build is that we would make jewelry that they could get up in the morning and change the color of to match their outfits, right? So like if they're wearing blue that day, they'll be like, oh, this is cool, like I'll make my bracelet blue and I'll wear it today. And then, so when I ran that idea past them, they were like, that's not really fun, that's not very cool. And I was like, oh, okay, well, I mean, that seemed like I would like that. What would you be into? And so the things that we heard that were important to them over and over again were friendship. My friends are very important. Knowing who my friends are important. Talking to my friends are important. So what we landed on is giving them a way to talk to each other while they're in class, right? I mean, how important is that? You want to pass notes? Why not have a wearable that lets you talk to each other? And they're excited about that. The one thing they're more excited about is the ability to sense their friends. So friend groups, when they're together, their bracelets match. So if I'm friends with Stacy, who's over there, and Jenny is over there, you can see from my bracelet that it's half Jenny's color and half Stacy's color, and we're friends. And that's something they freak out over, and as an adult, no adults get that. But they get, every time we talk about it, they get so excited. So what we landed on, which was pretty neat, we learned that kids really aren't allowed to have their cell phones in school. Some of them sneak it, and they try, but really they get their phones taken away. So how could we make a method of communication for them that doesn't depend on a cell phone? Because right now wearables really depend on your cell phone to get internet access and things like that. So we landed on building a mesh network of wearables. And allowing the girls to piggyback off each other. So I get 30 to 50 feet of range using my device alone, but my device plus her device gives me exponentially much more range. And so that's something we've been working on for a little while. And we think it has lots of applications. I mean, even think about that age group, right? Like, imagine playing Manhunt, and you're like your team leader, and you're outside, and you're like, whoa. You're like, all right, squad leader, over, and like you're running around. I think that would be really fun if you're a boy or a girl. And also in situations where you want privacy and you don't want to depend on a cell network, or in a situation if you're on a manufacturing line and you need to communicate quickly with a supervisor and you don't want to depend on the life of someone else, that they have cell service. So we ended up patenting that concept, which was a crazy process. And that's something I think that, there is patenting in the software community as well, but it wasn't as important, it wasn't as promoted. So we had to work with a patent attorney, which is crazy. And what patent attorneys do is they search existing patents. They find anything that's close to your patent. They tell you what parts that you can own, what parts you can't own. And patents are super pedantic. That is what I learned. Like, you have to explain things like you are talking to a 3-year-old. And all kinds of drawings, which was a crazy time-intensive process. But that was something else that was really cool to learn about building a hardware company. So now that we had our concept down, we started talking to them about what they wanted to see. And in the hardware world, there are 2 types of prototypes. There's a look-like prototype and a works-like prototype. And the reason for that is often you want to prove a concept that your technology can work, while in conjunction with the fact that you're working on designs and you're running designs past your users. So you can, often, those things don't happen together because of size constraints, or you don't want to limit the look by this larger hardware. You might be using Arduino to prove the concept. You don't want to have to fit this big Arduino in this tiny device. So we started working on both, and we talked to them about designs. And what we did is we worked with high school classes in the Bay Area. We sent them just like a crap ton of designs, and we were like, pick a design, let us know. We'll let you guys decide what this looks like. So they voted on it, and they picked a couple designs, and we got started on building out the look and feel of a Joule bot. And so meanwhile, we were working with the engineers at Highway 1 to build our own custom boards for our Works-like prototype. And this is our first board. We'll be open sourcing all of this because I think it's really important that people can learn from other people's experiences. This is an RFduino, which is an Arduino-based microprocessor. It's a microprocessor that has an Arduino library on it, and allows you to use the Arduino IDE to code it. So this is a little larger. You can't really get scale here, but it's a little bit over an inch by about a half an inch. So it's bigger. If you wanted to put it in jewelry, it would be kind of large. And we put a motor in it in order to have vibrations, and there's a button right in the middle. And this is our light board. We decided that we wanted to try 8 lights. They could customize each light to work with their device. And we were working with mechanical engineers at Highway 1 on the design of the Works-like prototype, because even though it was bigger, we wanted to give them kind of an idea of what they were working with. So we built something that puts all this together in one neat package. And it is so, like, debugging in hardware has so many more implications than debugging in software. Debugging in software is hard enough, right? But when you're debugging in hardware, you have firmware, you have your hardware, you have your things your industrial design and things that, so for example, one of the bugs that we had with this unit, which literally took us about a month and a half to figure out, and about 10% of our demos failed, like all the time. So we were really unsure. In the beginning of a demo, we're like, we really hope this works. And what we figured out was, so the way I coded this device is that you could turn it on and off using a long button hold, kind of like you do with a phone. So you hold the button down, turn it on and off. And what would happen is, like I said, 1 out of 10 times you couldn't turn it back on again. And then I'd play with it, and I'd have to do some soldering. And what it turned out, what was happening is when I was doing the long button hold, one of the wires was coming loose all the way on the bottom of the device. And I mean, it sounds obvious now with me saying it, but it took us forever to figure it out, and it was so frustrating. And once we did, we were like, oh, that makes so much sense. So the debugging is infinitely more complex. Yeah, but it's awesome to find it out. It's awesome to learn it. And so something else we did is we designed the charms. So one thing that we're doing is one thing we heard from our users is that they like to customize their jewelry. So we heard monograms a lot. They want to express themselves and who they are. So they wanted their own designs. And as we know, fashion changes all the time too. So how do we keep up with young girls? So what we designed the product to do is be interchangeable. So you can take the electronics out from one charm and put it into another. That also allows people that aren't teenage girls to 3D print their own cases and things like that if it's something that they want to use. So we designed 2 charms. We 3D printed a ton of them. There's a great resource called 3D Hubs. And I know there's other resources like this, but if you go to 3dhubs.com and you upload a 3D design, you could get it printed and mailed to you fairly quickly. And you can choose the resolution of your print. So for a little more expensive, you can have a better looking print, or for something kind of cheaper, you can have a really rough prototype. And then we found manufacturers in the Bay Area that help us build these things, because we were working with things like injection molded plastic and aluminum. or aluminium, depending on where you're from. And something that I can't stress enough right now, and we learned this the hard way, is before you get to this step, make anything, like 3D print, cut out of cardboard, do whatever you can to get the feel of what it's going to be like before you go to manufacturing. So something that happened to us is that more recently with our current iteration of our board, we decided to go with a little bit larger of a board, so 33 millimeters across, in order to have longer battery life. So battery life is really stressful in wearables, and the size of the battery really matters. So we were like 33 inches, that's only a little bigger than, sorry, millimeters. 33 millimeters, it's only a little bigger than a quarter, that'll be fine. What we didn't do is sit there with some cardboard, measure out 33 millimeters, cut it out, and see what that would look like on my wrist, see what that would look like on a 10-year-old girl's wrist. So we got our boards when we manufactured them, the most current iteration, the most recent iteration, we got them, and we were like, holy crap, these are huge. Girls are not gonna wear this. And then we were like, we wasted so much time figuring that out. So lesson learned, test these things at home as much as you can before you actually go and build them. So this was our looks like prototype. This is actually a video if you don't mind playing it. This is when we were testing the messaging functionality. We're just being able to communicate across the room with a device. And so what we did once we had this is we got some girls in a room, we gave it to them, and we got feedback from them. Explaining to them, what you're gonna have is smaller, but what do you think about this? How does this feel? How do you react when they get close enough for each other to sense each other? And how is 30 feet enough? Is it too much? So that's some stuff we were testing with our users, and we got great reactions from our functionality, which was exciting. And we got great reactions from the look and feel of what we sent them, the 3D printed versions. So we refined that, and we manufactured them to look like this. So this is our final looks like prototype and what our device is going to look like. And as you can see, inside is the mechanics that you can take out and interchange with different charms. And so this is our most recent board of what I was telling you about. And one really neat challenge of building a hardware company is no longer just hiring software engineers. So I've interviewed a ton of software engineers, and I've gotten to a point where I feel really comfortable saying, or I feel really comfortable with the fact that I can identify a software engineer that would be good to work with. But when you're building a hardware company, you're hiring electrical engineers and mechanical engineers, industrial designers, and this isn't something that you do. Well, this isn't something I have any comfort with, right? I don't know anything. I know about Arduino, right? So it doesn't really lend itself for me testing like a production electrical engineer. And so something that would always frustrate me as a software developer when I would talk to founders that weren't technical is when they didn't know how the internet worked, right? Like, what I would always think is, you don't know how the internet works, but the export of your company is internet. Like, you are building internet. You need to know how the internet works in order to do that. You don't need to make your actual application, but you need to know how it works. So that's something that I really attempted to do, both with mechanical engineering and electrical engineering, was learn at least, I'm not gonna be able to do it, I'm not gonna design a board, but I went to board design classes. I designed 3 really crappy boards. But at least I know how to design a board now, so I can have a conversation with people saying, what part of this energizes you? And it made me a lot more comfortable hiring this type of person. So I encourage you, if this is something that you're thinking of doing, to just get as comfortable with it as you can. You don't have to go back to a 4-year school, but get comfortable with talking to these people that do this for a living. And so this is our board. This is what we ended up with. And so like I said, it's a little bigger than a quarter. We're still iterating on this model. And this is our most recent prototype. You can play this. See that little guy? He's such a little guy. That's where we are now. We're still iterating on it. Between us and manufacturing, there's a Kickstarter, some crowdfunding, and a few more iterations. But it's been super fun to build. So we're still in the process, but it's been a really cool process. I can't recommend it enough. One thing that's been so neat for me is when I first started coding, I was just so excited and so energized by being able to build something and sit there and debug for a few hours and finally figure it out and get there. And then after that, I got, I just worked, I coded so much that it just became like second nature. And then I got into management. But one thing that hardware has helped me do is kind of find that side of myself again, to find that like creativity side of things. And so I can't recommend it enough. And so that's us. That's JewelBots. Pay attention. Check us out. We're hoping to launch the end of the year this year. So thanks, guys.
I think we have time for a couple questions. Does anybody have any questions?
One question I have for you guys. I was going to give away a Spark Core, which is a Wi-Fi enabled Arduino, and I was trying to figure out who to give it to. That guy in the back. I'm just kidding. Sorry. So I figured I'd ask, is anyone here a student? Is anyone like still in school? Okay. Is anyone in high school? No high schools. All right. Is anyone a freshman in college? A sophomore in college? Okay. I saw your hand first, so you're gonna get it. Okay. Okay. Awesome. Go backwards. Great. Does anyone have any other questions?
Over there, PJ.
Hi. Have you filed any patents yet?
I can't really hear you, sorry.
Have you filed any patents yet?
Yeah, so we filed a provisional for the patent that I discussed. So in about 6 months, we're gonna have to do it again with the big time. So that's been interesting, yeah.
This PJ, last one.
How are you looking at scale? There's always the issue with hardware startups going from the 3D printed, low volume stuff to, I'm going to sell hundreds of thousands of units. How are you looking at manufacturing partners?
So one thing that we were lucky enough to experience now through the hardware accelerator that we did to Highway 1, the parent company, PCH, is a large-scale manufacturer, and they make Apple products and Beats by Dre and awesome things like that. And we've had mentorship from them the entire time, which has been great because they've been doing this for a long time. So that's what I would recommend, is find people that have done this. And even people not at PCH that we've talked to that have done this have been really valuable because they can tell us there's so many learnings from doing it the first time that they can help you out a lot.
Awesome. Sarah, thank you so much.
Thank you, guys.